All right, so objective 1.1 is all about Rutherford and his gold foil experiment and what he brought to the tables through the evolution of the atom and this atomic theory. So we first started, let's first start with a quick recap. So Dalton kind of started developing this idea that an atom was a sphere, but there was no necessarily real particles, just a sphere. He called it the billiard ball model, like a pool ball, something like that you would play pool with. Then Thomson came along, did some more tests, and discovered that there were particles in it, positively and negatively charged, but there was no real organization. That's why they call it the plum pudding model. And here in America, because we really don't have that much, I don't know, kind of ideas of what plum pudding are, we call it the chocolate chip cookie model. Those chocolate chip cookies have chocolate chips kind of scattered throughout and no real organization within it. But Rutherford, which we focus on in this objective, definitely came up with that. There's the idea of a organization of the atom, and that's what we're going to take a look at. So when Rutherford came along, he set up a experiment, which you can see on the right, where he had alpha particles, and the alpha particles were coming off of a nuclear decaying element. So when elements decay, they emit energy, and they emit these positive particles as well. So what happened was we then had, he was shooting it through thin gold foil into a sensor, which was right here on the other side. So very similar to your marble experiment, where you could see the marbles going in, and you could see the marbles going out, but you couldn't see them, see what was happening under your board. The alpha particles, when they were being emitted, they were being shot through, and he was seeing on the other side of the sensor that most of them were actually going through unscathed. And he kind of had that idea that that was going to happen. But the thing that he didn't know what was going to happen is that when they were going more through the center, they were being deflected off of some sort of barrier. So a couple of observations that he had here, and you guys can see that in the chart over here. The first observation was most of the particles had passed through. Okay, so if most of the particles are passing through, then most of the atom has to be empty space. So again, if we think about hitting the target in class, it was really small. So most of you guys were hitting the empty space. And if we even think about, if I made the target even smaller, like it should have been a grain of sand if our room is the atom, it would probably be pretty impossible for you guys to hit. But I wanted to give you a little bit of, just a little bit of the chance to get that. So most of the atom is empty space. That is one of the big conclusions. But he discovered that there was a nucleus, and the nucleus was very dense because nothing was passing through it. It was kind of like a wall, like nothing's going to pass through it. Things are going to deflect off of it, or a pole or something like that, or something that's not necessarily very big. But what he also discovered, what it was positively charged, because all of the alpha particles over here, if those are positively charged, they were deflecting off in such a manner that it was like, oh, well, this has to be positively charged too, because they're deflecting. They were repelling each other, and like charges repel. If the nucleus was negative, then the positive particles would actually probably attract, or they would stick to the nucleus if they were hit. So again, he came up with this idea that, one, it's dense because it can't pass through, but two, it has to be positive because it's deflecting off. So the whole part of this was discovering that there was a nucleus, there was some sort of organization, and there was a core as opposed to just them scattered throughout. So again, he discovered that there was a nucleus. It was dense and positively charged, but most of the atom, just like we talked about in class, is empty space. So that nucleus, while it is dense, doesn't have a great volume. So most of the matter that we talk about is coming from very, very little volume. So most of the matter actually is empty space if we think about atoms in general, which is kind of mind-boggling. So Now, at this point, go through your objective and take a look if there's any questions that you have. If you feel good, assess or create your alternative mastery. If you don't feel good about it, make sure you ask questions. Also, kind of relate this to the activities that we did in class with the bag, the marbles, and the target practice to help you with these ideas as well. Good luck, and let me know if you have any questions.